Okay, good afternoon, gentlemen, and thank you very much for attending for yet another lecture about Docker containers and Kubernetes orchestration, which is sponsored by FAB-IT Solutions. In this particular lecture, we have many references to the previous one because some of the aspects of the Docker and the Kubernetes can be also implemented in AWS. Docker concepts. Docker is a platform for developers and sysadmins to develop, deploy, and run applications with containers. Containers, as far as I'm concerned, they are not that much of a difference to their virtual machines. The only useful purpose of them in comparison to virtual machines is because of the process slicing. And the virtual machine is basically taking a lot of resources. So the main difference between the Docker CE and EE version is similar to Linux Red Hat Enterprise Edition compared to CentOS, that is community driven.
CE is community edition and EE
exactly.
Enterprise Edition.
Correct. Right. So basically, Docker EE has Enterprise Management Console that makes it easier to manage Docker containers, but that does not mean CE has any limitations, specifically for you guys or engineers that would like to have hands-on. And a lot of the controls are command-driven. Here we'll be covering Docker CE on a CentOS 7, reason being that it's a good complement to being open source, which is a version of the Red Hat Enterprise Linux. And the knowledge can easily be transferred to any other Linux systems, i.e. Ubuntu. The packet management could be a little bit different. You would use apt-get in Ubuntu. In the CentOS you have simply RPM and the Yum repository management. Containerization is an increasing popularity because containers are flexible, lightweight, interchangeable, portable, scalable, and stackable. So even the most application can be containerized. Always get this word as a tongue twister. It's not actually a word, it's a self-made mode. Containers leverage and share the host kernel. You can apply updates and upgrades on the fly. You can build them locally, deploy it to the cloud, and run anywhere. Because of the model that it has, the container itself can have a separate storage. And when it's deployed into the cloud, the storage can be actually portable and deployed into the cloud. You can increase and automatically distribute containers replicas. So the replication is not much of a problem because when you create a container as a sub-process, it can be multiplied and applied. You can stack services vertically or on the fly. So if you have a more volume and more need for the services, multiple services can be stacked up. And the main difference between the containers and the virtual machines is containers runs natively on Linux and share the kernel of the host machine with other containers. It runs discrete process, taking normal memory and making it lightweight. This is what I just previously referred to because when in the Unix you have a virtual machine that will be sitting on a hypervisor and directly communicating with the hardware. And most of the times, if you look at your systems, your virtual machines are taking lots of resources that they're just sitting there doing nothing. So when you run a VM stat, you see the CPU is idle, I/O is idle, and storage is also idle. Well, here we're not focusing that much on the storage, but from a CPU and the memory perspective. Since it slices the processes into segments, the CPU can be used in a more effective way. Pretty much like the virtualization on the IBM Z series, that you can use portions of the CPU instead of one CPU as a total, and you pay for it accordingly. But in this particular case, also it's very price effective. So you can segment your CPUs amongst the Dockers by using less percentages and running more applications. By contrast, a virtual machine VMs run full-blown guest operating system with a virtual class to host resources through hypervisor. In general, VMs provide an environment with more resources than most applications need, which we just mentioned. Now, in order to show you that, you can see here you have a container model. Here you have a VM model. In the container model, you have the app B, binaries and libraries, sitting on the Docker and the host OS, connecting to infrastructure. So here it's very simply visible why that is more efficient when a virtual machine is sitting on an app B, bins, libs, guest OS, and a hypervisor on your infrastructure. Obviously, it's going to take a lot more resources. Now, within the Docker, the model is like this kernel here. So you have the client Docker CLI. You can manage the container, image, network, and data volumes. And that is what we basically are going to cover in this particular lecture. To give you an overview, when you want to get a lot deeper, there are a lot of concepts that can be also discussed in the further lectures that we might have later on, depending on the customer. So in the middle you have the REST API, and the server would be the Docker daemon. And the Docker daemon is basically the process that is running on your VM.
What is the difference between Docker CLI and REST API?
That is the CLI layer speaking to the Docker daemon or the kernel through the REST API, which we have some examples.
Yes, I understand. But what is the difference between CLI and REST API?
Well, CLI is a command line interface.
And REST API?
REST API. Well, REST API is not command line. It's not bash. So you have to use REST syntax to be able to make the connection from a syntax perspective.
But you can call the REST API over the command line interface, or?
Exactly. But
yes.
your command is not actually doing the work. The REST API is doing the work.
But the command is another call with REST API.
Another shell around it.
Yes. But what is the difference? Is Docker CLI is the command interface.
Yep.
Docker stop, Docker start,
yep.
whatever. And the REST API, I know the REST APIs, whatever REST APIs is, from my experience, is more powerful as a command interface. It's also for Docker?
It is possible, but the powerful is depends on the perception, because the CLI could be a simple bash script accessing it, but some of the CLIs are actually calling a Python script.
Okay.
Right? But when you have a REST API, it's a simple REST API without any shell around it.
Okay.
So that CLI command line interface is not always bash. So it could be a direct bash when it's very operating system relevant. But normally when it's deeper into this...
It's also available for PowerShell and Windows, I know.
Yes, we are not going to discuss Microsoft in this.
I know. I know. I work with them.
Yeah. The Microsoft is out of scope. I'm not going to make references to Microsoft. Any other questions? Now, this might be interesting. For the underlying technology, Docker is written in Go language, actually. It takes advantage of several features of the Linux kernel to deliver its functionality. That's why I don't want to talk about Windows, because the Docker implementation on the Windows is actually building a Linux kernel on top of the Windows operating system.
Really?
To be able to run.
Oh my god. Okay.
Docker only uses namespaces such as following on Linux. So the actual Docker internals run on the PID namespace, which all the Linux people or Unix people are very much acquainted with, is a PID process ID. The namespace managing network interfaces is just a net at the Linux level, which is networking. IPC namespace, even the name is exactly like the Linux. So interprocess communication. The MNT namespace, managing file system points, MNT mount. So if you're familiar with the Linux, it's not much of a challenge for you to pick up Docker. Even the modules that you download in order to run the Docker are directly connected to LVM for logical volume managers, or some sort of interpretations of that, which we're going to cover in a second. And the last but not least, the UTS namespace, isolating kernel versions, identifiers, like in this time-sharing system. Now, in this particular lecture, we're going to have a little bit more command line, and it could be a little bit too involving, but we don't have a choice. Because we are running a Docker CE, we don't have that much graphic user interface. So you have to bear with me. So for the installation, for the ones who are already acquainted, we are using Yum, as we are using the CentOS system here. So if you're using other implementations of the Linux, such as Ubuntu, then you'll be using apt-get, but it's not that much of a difference. So you can see here, actually, we are listing whether Yum utils exist, device mapper, persistent data, LVM2. So in the Docker, you can have two different forms of storage, data storage. One of them is on the fly. Sorry?
The first line, Yum utils, device mapper, or LVM2, this is also dependency for Docker?
We'll cover it in a second.
Okay.
So the device mapper is absolutely necessary. LVM2, if you use it, it's necessary.
Device mapper and LVM is combined.
Exactly, because there are three different models of accessing data. One of them is persistent, the other one is in memory, and the other one is, we're going to cover it in a second. So here, if you don't have it, you have to make sure that they are existing, and after that you do yum install Docker CE and the CLI and container DIO, which is your daemon. When that is installed, then in the systems 7.1 of the Red Hat, everybody's acquainted with the systemctl, so you run the Docker with the systemctl in a system 5 construction manner, and that's it, then it will be installed. To be able to check it, as you know, you can do systemctl status Docker, the status of the Docker. Now here we're going to run Docker run hello world. Run is basically when you want to run a container, and this container could be an application, or it could be an image that is made by someone else. What does that mean? It means like you can either run a full blast Ubuntu operating system by run, or you can develop an application and use the run as well, and you containerize your application to be run, or any third party that is available. In this particular case, when I say Docker run hello world, because this image is not existing, automatically downloads that image for you, if it's available, and runs it for you. So to generate this measure, Docker took the following steps. The Docker client contacted Docker daemon. Docker daemon pulled the hello world image from the Docker hub, which we're going to cover later on. So whatever image that you call and is existing in the hub, it will automatically create it for you. So although it's a command line, it's very, very user-friendly. It's not that much involving. You don't have to check dependencies, nothing. Now, here it says try something more ambitious. Docker run IT Ubuntu bash. This is very impressive. Why? We're going to get into that in a second. First, a little bit of a preview about basic information. You basically pull that hello world in this particular case, which is a very simple program. You can see it's been tagged as latest. That's your image ID and when it was created and the size. And if you do Docker container ls-all, it will show you all the containers that's been running in a list. That means including the containers that are not running at this point. So if you omit the -all, then you get the running Dockers containers at that point. So therefore we have images that could be not running, sitting there to be run. And we have containers. You have the running containers that you can list. And you have the historical containers that's been running before, from a statistical analysis. Now when you do Docker info, there are lots of information here that are very useful when you get more advanced in Docker. And in this particular case, you can see it's saying you've got 3 containers, 0 running, post 0, stop 3. You have 1 image. server version, storage driver, overlay 2. This was your question. So in this particular case, we're using overlay 2 instead of the LVM. But LVM is also possible to be used, which we're going to cover later. So you have JSON file for login drivers. Here you got the plugins. Another interesting thing that we are going to cover is the swarm. At the moment you can see it says the swarm is inactive. Runtime is run in C. Default runtime is run C as well. Init binary is a Docker init. And the rest of the information is basically detail. So you have the kernel information, you have the operating system information. In some cases, these are necessary to be known. How many CPU you have, how you're going to slice it up, what sort of architecture you're running on, total memory, and so on. In this particular case, I turned off the firewall, so you can see the bridge NF call IP tables is disabled. I didn't want to make it unnecessarily more complex. Any questions on this particular side?
I have no understand the difference between image and container.
Sure.
The container, you have 3 containers in one image, and every container can access the image. Is correct?
Okay. You have an image, number 1.
Yes.
To be able to run it, you call a container from that image. So that image is dead. The container is live.
Okay.
So it's like an image of a system that you have, then you start up a system, like a VM.
Okay.
It can be sleeping or it can be running.
Okay.
So the image is a sleeping container. So when you wake up the container, then it will be running. You can see it in the running section by saying docker container list. But then you can have a list of the containers that they've been live in the past to get some statistics.
Okay.
Then you do docker container ls -- all. Then it will show you all the previous history of running. Does that make sense?
Yes, I know. I know from kubectl it's the same procedure. You can kubectl delete bot, and then you have delete the actual bot or container, and then was automatically generated a new container or new bot, and it is from the image.
As a matter of fact, you're referring to Kubernetes. Kubernetes is, I mean, to me, it's nothing special. All it does is, I mean, if the Docker is not there, Kubernetes will not even work.
Okay.
Kubernetes uses Docker internal system to be able to manage larger amount of containers. So yes, the commands are very similar. So if you have that understanding, is exactly you can port it.
Okay.
It's exactly the same understanding.
Okay. One container can also running for one image actually. And
You can have 5 containers running for one image. We're going to cover it in a
Okay.
second. Yeah.
Okay.
That's where the swarm comes in.
Okay.
And that is what I would like to emphasize. The Kubernetes doesn't explain to you that much about the swarm, and a lot of things are done for you. So from my perspective, Kubernetes is actually easier to use. Everybody's talking about Kubernetes from a management perspective, but if you understand the Docker, Kubernetes is going to be very simple.
Okay, I have understand kubectl.
Okay.
Okay.
Now here I have a very simple example. On the aspects of development, sometimes test application on a different platform with Docker is easily achievable. So if you have a CentOS system and you have a specific application that's been written for Ubuntu, what you can do is simply run the Ubuntu as a Docker and go inside the Ubuntu operating system and test your application.
But then you would lose the advantage you mentioned before that you have this limo container then when you
Exactly.
used to be.
Exactly. That is not for that purpose. You're exactly right. The purpose for this is that I want to test my application on an Ubuntu environment, but this is not production. It's more a development aspect of it. But it was a very simple example and a powerful example that you're in a full blast operating system within an operating system. So when Ubuntu comes in, you don't even notice that you're in CentOS anymore. In below example, you can see that it's possible to run an Ubuntu SOS container directly on the CentOS using available Docker images. So what we do is simply we write, say docker run it ubuntu bash interactive terminal. So I'm saying give me Ubuntu, give me an interactive shell in a bash, and give it to me. So it does it for you. It does the pull from you from the Docker hub, and suddenly you're somewhere else. You're in a parallel universe. Now in the parallel universe, to prove that you're not in the CentOS, you do apt list. So the yum is not even working anymore. You're in Ubuntu environment with the apt package manager, and you can see all the packages are there. And in this particular case, when you come out by Control-C, by exit, you do docker image ls, and you can see that Ubuntu was running 12 days ago, so it's in the list, although you're not in the Ubuntu anymore. So when you're in the Ubuntu, you don't have any idea from the mother universe. So you went through the black hole, and you're in a different galaxy, if it exists on the other side of the black hole. So in this particular case, we do ls all to get all the different containers in the list, and it comes to a point that you don't want to have that list in there anymore. So you have a container that you want to delete all the previous information. You simply run docker container prune, and as should you want to do it, then it just deletes all the unnecessary containers, and it also only gives you the ID of it. You can do the same thing with the images, because all these things cost space. So if you want to clean up the space, you do docker image rm, and you call the image number, and we delete it. In this particular case, 256 bytes was saved, so it's not really significant. Any questions?
Just for understanding,
Please.
To distinguish containers from images, again, let's say I download Ubuntu as an image.
Correct.
And then I do some changes inside. They would be saved in the container itself. And
No, it's not. No, it's not. Correct. What happens is we save in your live container, but as soon as you close that, it is not saved in the image. You have to create a new image and send it to the Docker hub. Then you have a new image of that. Very good question.
So I can't have the images myself. Let's say I want to.
You can, but you have to build it. You have to build it and submit it into the Docker hub, or submit it locally, which we're going to cover in a second.
Okay.
Very good questions. Exactly like operating systems. You do the configuration management, you save them somewhere as an image, and you call it. To be honest, there's no difference at all. Just don't think of a Docker, just look at it as another VM, but less facilities or very specific facilities. Why specific? Because this should answer your question. So here we're creating an image. As a matter of fact, this is exactly the answer to your question. So for the people who are acquainted with the Python, we are writing a Python application here, and for that we have the Flask and the Redis and Redis error necessary. So it's a very simple application. All it does is Redis is an inline database which is NoSQL. So everything, all the information is held in the memory. So we're creating the sockets for connection, and all we're doing here, we're sending out an error message that cannot connect to Redis container disabled. So this is our application. So this application could be our operating system. This could be anything. Could be Nginx, a particular Nginx configuration. So when you have that, then you have to have some sort of a configuration for this application to be built. For the people who are familiar with the C programming, in the C programming you use make. So this is some sort of a make file here. So you say, I need Python 2.7 Slim. This is my working directory. This is a copy directory. And I need to run pip install trusted host Python org requirements with the requirements txt and expose 80 port and the nf name world And then in the requirements that you're referring here, you have to put Flask and Redis because you're making the code inside the application. But we're not going to cover this because it's not a Python scripting, but it's a simplified Python application that we've written. So you have 3 files here. So you got the application py Docker file and the requirements for this particular case. Now, in order to construct that, like building any other applications, you say Docker build, and you tag it. You can tag it whatever you like. In this particular case, I called it Python Redis, because it's Python using the Redis module or library. So it does a build for you. It calls even the pip install for you, and tags it and makes it ready. Successfully tagged Python Redis latest.
The files, the Docker file and requirement text, that's your own sample?
Correct.
Okay.
You have to create it yourself,
Okay.
and you just put it there, and there is a format. You can look at the syntax and check the syntax what is necessary, and depending on your Python program, then you have to change it.
Okay.
Now here you can see that Docker image ls, now you have Python web server. Well, it was Python Redis. The reason here is called Python web server because I did 2 different runs. Here I called it something else, but it's supposed to be Python Redis. Sorry about that. So basically it's your Python Redis, but meanwhile it had to download the Python 2.7 Slim as well. Because I didn't want to get a full blast Python, I just got the Slim one for this particular application. And you can see Hello World is still there too. Now does that mean it's running now? After this step, do you think it's running now? We did the build.
It should be.
No, it's not, because it's image now.
Yeah, but you can run the image.
You can run the image.
Did you ask that?
That's the next step. We're going to do run that particular image.
And now I got you. I misunderstood.
No, okay. But this will explain to you your question, what is the difference between image and that. Now we're creating a running container out of that image.
Mm-hmm.
In this particular case, I'm sending the port from 80 to 4000. You can run it as a daemon or detached, but in this case we're not running it, we're running it as a command.
You can give it up the port forwarding?
Yes. It's got at least 30 different flags you can give. This is, I just wanted to simplify it.
It's nice.
Yeah. Very, very powerful. So here I'm basically defining, it'll get more interesting. You can put it in YAML.
Okay.
Because when you're creating swarms, we get to that. So,
so port 80 is only from the inside container view, port 80. From the outside, you
It's
just
4000.
connect it with Docker to a different one. Okay.
Mm-hmm.
And to prove that,
for port 4000 you connect on the port 80 from the container.
Yeah, but only the container itself or what is running inside the things
Inside.
will be port 80.
And you can then but this construct, if you use this construct, you don't need virtual host by HTTP, Apache.
you don't have web server.
Yes.
Yeah.
There's one web
That's the
server,
whole point.
and you create many containers with other ports, and you can testing.
Yep. Okay. Now we're getting a little bit.
Okay. It's too much.
Yeah.
Sorry.
Because we have to finish it. This is already. What we are going to cover here is going to already take 2 hours, so you're going to be exhausted by then. So. So we'll be running it here as a web server, and simply what I do is then I do a CURL, localhost 4000, you get the answer, and here is a little bit nicer version of it. I say 172.160.10, 4000, and it's coming up.
I love it.
Now, working with the Docker Hub, it is important that you have some sort of repository to be able to organize your images and the operating systems. Similar to when you're coding, you need a GitHub. So this is a Docker Hub, exact same concept as the GitHub. Although simple, we're going to quickly go through it. So what you do is, after you created it, you have to tag it. You say Docker tag Python Redis. It has to be in this particular syntax for the Docker Hub. So first you go to the Docker Hub, you create your account. Then you, on the command line, you say Docker Hub login. You log into your account with your username and password. From then onwards, you have a communication with the Docker Hub. Then you say, in this particular format, you say user repository, and the tag. Tag is a version. So because I've logged in before, I didn't put it here, it just tabs it in the FAB-IT Solutions examples version 1.0. Then you can see the tag here, FAB-IT Solutions example 1.0, 4 minutes ago, 131. And you can see the local version as well, which is Python Redis. When that is done, you do docker push FAB-IT Solution examples v10, exactly like Git, so it's pushed to the hub, and it's there. Okay, it's a bit messy, but soon we're going to go to the graphic user interface so you can see it better.
But the hub is your own hub.
No. The hub is actually it's a service. It's a service that's given by Docker Hub. And now in this here, what you can see, I'm doing a Docker run minus P4080, but this time I'm not calling it local, I'm calling FAB-IT Solutions examples 3.0. So if you go to a different machine, you simply connect to the Docker Hub and pull the image down and you run it. No hassle. Now this is the Docker Hub, how it looks like. When you log in here, you can see that's my company, FAB-IT Solutions, and examples was the repository that we were referring to, and FAB-IT Solutions is the username.
Okay. You need your own account for Docker Hub and
Exactly.
and you can create the repositories for you.
Exactly.
Okay. No.
Which is very good because then you're balancing your repositories as well, but they're not all in one place. And you can see here we have version 1.0.
It's free?
Free.
Free.
I mean, within limits.
Okay.
But it's not necessary. You can also just have a local file somewhere.
Definitely. Definitely. Now, this is exactly what you're talking about. So Docker Hub and Git, they'll also have interactions. And when you go to the Docker Hub, you have an option to link to GitHub and link to Bitbucket. So they're both Git repositories. As you know, they're just two different companies. My favorite company is an Australian one called Bitbucket. I use a lot of products, Atlassian's. And since I'm using everything there, such as Confluence, Jira, Kanban, they are all Atlassian products, and I'm always supporting that. So here you can see that the Bitbucket is linked. The project is called Algorithmus, and you can basically turn the email off and on. It's got Slack as well, which I don't use, and it's a public. Now, when you change your code on the GitHub, you need to build it. So here you have automatic builder as well, so you don't have to do the build anymore. So as soon as you can create a trigger, as soon as you make any changes into your code, automatically creates your image and applies it to your target. In this particular case, we say also build and build caching on as well. And the repository is Algorithmus. You can do auto test, in this case is off. Here now it's building. And then you have the recent builds here. There you can see it in sequence. Success. So I made a change in my GitHub on the Atlassian Bitbucket, building master and the latest. This is a wrong logo. This is not GitHub. We're supposed to be Bitbucket, but it's showing GitHub here, which is not. Algorithms 8 minutes ago. Duration 1 minute. Use a FAB-IT solution, and it gives you IP as well. And you can see the Docker file, README, and the build logs as well. So here you can see all the information, origin master, coming from the GitHub. Any questions? Now this is the build overlook. So when you go to the main page, you'll see that recent builds on Algorithmus Docker. the Docker is your repository on the GitHub, algorithms is your project. So you build a master twice. And also it gives you how to push it. There's an option for pushing. Then you have the tags here. In the last one, if you don't give a tag, automatically puts latest for you. So if you don't give it a tag, when you're pulling as well, it pulls the latest for you. Unless you say which tag you want. Then we'll pull down the necessary tag.
And after that, if you send another one without version tag, it would override the latest one.
Exactly.
Okay.
Always the latest will be the latest.
So it wouldn't automatically just count up in the version number or something?
No, there is a facility to do that as well. I didn't get involved with that. There is a trigger, there is a automatic versioning as well. We're not covering Bitbucket today, but in a different lecture we could do that more in depth, because everybody uses Bitbucket here, but I've noticed not everybody knows it very deeply. Everybody's pushing into the main branch, and yeah. But anyway, this is a Bitbucket overview. I gave it a Docker name and a logo, so it's a GitHub. So these are your repository details. Docker training for decoding digital solutions. We have your access keys, aliases, and so on. Just to give you a quick overview about Bitbucket. Now, if you go to the code view, you can see that the Docker file has been pushed up. App py is pushed up. Your YAML is pushed up, and requirements in here, which is exactly the same as your server, which we're shortly going to cover the YAML. To summarize, the Docker Hub and GitHub, you can create a Docker file on your workstation, which we did. We pushed it to the Docker, to GitHub. We selected project from your GitHub repositories on the Docker Hub to build. So here there are two different pushes. I didn't show the Git push, we just did the Docker push, but you're already familiar with the Git push. Select the project from your GitHub repositories Docker Hub to build, and it triggers the build automatically. Then image gets created, and you push the image, pull the image, and then your container is ready to be run.
One question: if I need other package on my Access Docker image, not Docker container, I need other database example or whatever. It's just a way to update it. And must everyone create after install the new package, and then create a new Docker file, and then you use this procedure?
Yeah.
Okay.
This is the most efficient procedure. You can have shortcuts, not using GitHub. You don't need to use GitHub. You don't need to use Docker Hub. But it would be messy to manage it. This is a best way to manage it.
Yes, but I cannot install in my container. If the container destroy, my install package is done.
It's gone.
Then done.
Exactly.
Okay.
It's not persistent. But there are other ways to keep it persistent, which we're going to
Okay.
We're going to have a short breather now, also because we're streaming. I want to make sure that the streaming is working.